homework questions to go over, but all of them are on Riemann, and that's not my priority right now. So I will cover those probably tomorrow. I think I've got 4 questions to go over, but I'd really rather get through with integration, because y'all need to be working on 5.3 and 5.4 and 5.5 after today, because I'm going to go through definite integrals, which means, you know, the ones you actually have to do the math on. So with that being said, I'm going to go ahead and get started, and we're going to review a little bit and go over a couple of questions that we did. No, well, not exactly the ones we did last time, but some substitution just to get your brain flowing, and then we'll get into trig, and then we'll do definite integrals. I want to get into definite integrals before we leave today. Okay, so I'm going to shut this down, and I'm going to bring this up. And our first question is antiderivative of 3t squared times t to the third plus 4 to the 5th power dt. Okay, now before you get started, I want somebody to tell me, what is the indicator that you have to use substitution on this and not algebra?
Because it doesn't look fun to do.
Because of the 5th power, exactly. The 5th power tells you there ain't no way. So you're going to use substitution, and you're probably going to let whatever's in the parentheses equal u. So u is going to be equal to t cubed plus 4. Therefore, du is equal to 3t squared dt. Now I'm going to stop right there, and I'm going to let you do whatever you need to do the problem. So go ahead and start it. Give you a minute. So I'm going to rewrite blank t cubed plus 4 to the 5th power blank 3t squared dt. Well, it looks like to me we've got what we need, don't we? So 1 and a 1, and you don't need to put that there. I'm just showing you that I'm putting something where the blank was. If I needed something else, like a 4 or 1/2 or whatever the case may be, I would have put the opposite. You know, 1 times 1 is equal to 1. So in this case, I put a 1 and a 1. You don't have to do that. But if you do need something, it would go here and here. So I don't need anything. So technically, I've got the antiderivative of u to the 5th power du. Because, let's see if I can get this thing to work. I'm getting better at it. There we go. Because this is equal to, still not thick enough.
New Facebook comment.
I guess it don't get any thicker. I guess that's it. Is that. So my answer is u to the 6th over 6. So since I have u to the 5th du, I just say u to the 6th over 6, which is equal to 1/6 u to the 6th, which is equal to 1/6 parentheses to the 6th plus c, and plug in t to the 3rd plus 4. So that's a good test question that review over. So let's go over one that will, let's see. Okay, here's one. I'm trying to find the eraser. There it is, garbage can. I don't need to do the garbage can, I need to add. Oh well. Antiderivative of t squared parentheses t to the 3rd plus 4 to the negative 1/2 power dt. Okay, another minute.
So would you do to the negative 1/2? Because it's not technically the highest power, but since it's
No,
out
you
there,
would do
the
what's inside the parentheses.
the t to the.
T to the 3rd plus 4.
So that's the one you would use?
Yes.
Okay.
Most of the time, you'll use what's in the parentheses, unless you have a natural log, e, or something like that, then you would use something else. Most of the time, you're going to use what's in the parentheses. And you're usually going to go with the highest degree, and the highest degree in this problem would be the t to the 3rd.
Okay.
Okay. That's been about a minute and 10 seconds. All right, so the first thing I'm going to do is rewrite it. I'm going to write blank antiderivative of t to the 3rd plus 4 to the negative 1/2 blank t squared dt. Now, again, you're not going to see this in any book. This is a Hubertism. This is the way I took Dr. Hardin's explanation and I did this in my notebook. And it works. So what do you do next? Well, you go over here and you say U is equal to t to the third plus 4. Therefore, du is equal to what? 3t squared dt. So what do we need?
3.
We need a 3. And if you put a 3 right here, you've got to put a 1/3 right there. So now, since this right here is equal to du, and this is u to the negative 1/2, I have 1/3 antiderivative of u to the negative 1/2 du. And that's going to be 1/3 parentheses u to the negative 1/2 plus 1/2, I'm sorry, 2/2 over negative 1/2 plus 2/2. I'm just doing it step by step. You don't have to do that. I'm just doing it. And that's going to give us 1/3. I'm just leaving that out front. And that's going to be u to the 1/2 over 1/2. The reason I'm doing these step by steps because they're fractions. And I know that some of y'all suck at fractions, so I'm going to show you that if you do it step by step, you won't suck at it. Now, what do you do when you divide by a fraction?
Multiply by the reciprocal.
So that will be 2 over 1 times 1 over 3 times the square root of u, or square root of whatever you got. Square root of t cubed plus 4 plus c, and that's going to be 2/3 square root t cubed plus 4 plus c
to the third power.
And you could write t cubed plus 4 to the 1/2 power if you wanted to. I just went ahead and changed 1/2 power to a square root.
Who spoke up? Someone said something.
I'm sorry, what?
I don't know. Someone said something. No.
Okay, speak up.
I think O'Quinn said to the third power, but I'm not sure where he was talking about.
No,
Mr. O'Quinn, speak up.
It was something else. Sorry.
Okay, he's drunk. He probably don't know what he's talking about.
Probably.
Yeah.
Liquor at work.
Yeah, good liquor. All right, so now we're going to talk about trig. That's 2 review problems of what we did yesterday. So here's our first trig problem. Antiderivative, sine of 3x dx. Now, if you noticed, I put parentheses around the 3x. And there's a reason, because that's what you're going to focus on. That's what's inside the what? Parentheses. So I'm going to take my handy dandy translucent marker. Translucent. Parentheses. So I'm going to rewrite my problem And this time, I'm going to put parentheses, I mean a blank here. Sine of 3x blank dx. Just like I did before. So somebody tell me what u is going to equal. U is not going to equal the trigonometric function. Well, Hubert, I remember when I was in, it will if it's a square or a third or a fourth power or something like that. If you have a sine squared or cosine squared times sine or something like that, then yes, that's a different animal. This is a cat, that's a tiger, okay? So when you have parentheses and you just have a sine to the first power, you're going to use the 3x. So du is equal to what? So we're going to need something. Let me turn my translucent off and bring it down. So we're going to need a 3 here and a what?
1/3.
And finish it out. I think y'all can finish it out because y'all have a cheat sheet that tells you what the antiderivative of the sine is. So you have sine of u du. So if you have the sine of u, you just take the antiderivative of the sine of u, and that's your answer. And you're going to have something out in front of it. So this is 1/3. Ah, heck. You know, I know how to become a millionaire. All I have to do is invent a headpiece that goes on a teacher's head and thinks and communicates with this board, and I would be a millionaire. 1/3 antiderivative sine of u du. So if I have the sine of u du, then that means the antiderivative of the sine of u is negative cosine. Now I messed that up. Of u, which would be 3x plus c. And we've got something out front of it. So that negative and that 1/3 is going to come out. I remember my years at Clemson, you would be in the engineering in Lowry Hall, and they would tell you, do not put a circle or a square around your answer. You put 2 double lines. And then you go over to the math department, they tell you to put a circle or a rectangle around you. So now you could say cosine of 3x over 3 plus c. You could do that also. Negative. Okay, I think I wrote. Yeah, I think I wrote this thing down right. Let's add another one. Y'all throw a question out if you got one. I have found that these 2 blanks, they sure do help out. I don't know if any of y'all have had antiderivative substitution before, but I found these 2 blanks to be lifesavers. And add and white. So here's a nerd. Antiderivative, I'm gonna let y'all do this one. Antiderivative of 8 cosine 4x dx. I'm gonna turn the timer on for 1.5 minutes. You should be able to do it in 1.5 minutes, or at least get it started. First thing I would do is rewrite it with the blanks. All right, that's 1 minute and 30 seconds. You should at least have it down 3/4 of the way. I'm going to rewrite mine. Blank antiderivative cosine of 4x blank 8 dx. U is equal to 4x. du is equal to 4 dx. What do we have?
We have 4.
No, we don't.
Or you have 8, so you need it.
We got too much good in that shoe, don't we? So we're going to have to chop some of it off. So how do you make an 8 into a 4?
Multiply by 1/2.
Half.
And if you multiply by 1/2, you multiply the outside by
2.
2.
y'all getting on to this. Good job. So now, with this being 4 dx, this is cosine u du. 2 antiderivative cosine of u du, which the derivative of the cosine is the sine. So that's going to be 2 sine of 4x plus c. I bet y'all, some of y'all did that one and y'all just surprised yourself. I'm not even going to do that one because that would insult your intelligence. Let's move on to another. Antiderivative 9 sine 3x dx. All right, got a minute. All right, there's been a minute. Rewrite. Blank. Antiderivative. Sine 3x. Blank 9 dx. U is equal to 3x. Du is equal to 3 dx. So I need that to be a 3, so I'm going to multiply by 1/3. Now, a lot of you say, well, Hubert, that's just like the one I just did. We just did. Yeah. Oops, I'm sorry. Yeah, it is. But why am I showing you two exactly like this? Because students suck at fractions. That's why. So that's why I'm putting two of them in there. I think I got a third one, I'm not sure. All right, so 3 antiderivative sine of u du, because that goes to 3 dx. And that's going to be 3, and the derivative of the sine is the negative cosine, so that negative comes out front. Cosine 3x plus c. And hopefully some of y'all are seeing that the more you do, well, what?
It's easier.
You start to see the pattern. Just like if you're playing a piano and you have to do a shortcut with your fingers, the only way to do the best shortcut is to practice it over and over and over. I'm going to put 2 on here. Antiderivative 12 cosine 4 theta d theta. Antiderivative 7 cosine 5x dx. All right, there's 2. Now, if you do everything step by step, like I've been showing you, you shouldn't run into any problem. And I will rewrite first. Put some time on y'all. That's about 2 minutes. So the first thing I'm going to do is I'm going to rewrite that 12 is going to come out. Well, you could, let's see, you could leave it in there. Yeah, you could leave it in there and rewrite it as 12 d theta. So we'll go ahead and do that. I was thinking of the 7, but you could leave the 7. Think the 7, let's see, that would be 5 dx, so 4 do. Yeah. So I'm going to go ahead and rewrite. That's going to be antiderivative cosine of 4 theta blank 12 d theta. And blank out there. U is equal to 4 theta. Du is equal to 4 d theta. We've got a 12 d theta. So I've got to multiply that 12 by what?
1/3.
1/3. And if I do that, I get 3 antiderivative cosine u, and this goes to 4 d theta, which is du. So that's going to be the antiderivative of the cosine is the sine. So that's going to be 3 sine of 4 theta plus c. The next one. Now, the next one, I'm going to pull that 7 out because really 7 and 5 don't have anything to do with each other. Okay? So I'm going to pull that out, and you could have pulled the 12 out and multiplied by 4. You could have done that. I'm just going to pull that 7 out because that 7 and that 5 don't look like they have anything to do with each other. So 7 cosine, I'm sorry, I just said I was going to pull it out, I didn't. Sorry. There. Cosine of 5x dx. Now I'm going to rewrite it. I'm going to write blank 7 antiderivative cosine of 5x blank dx. U is equal to 5x. Du is equal to 5 dx. So I need to put a 5 here, and I need to put a what out here? 1/5. So now that's going to give me 7/5. What's the derivative of the cosine? We just took the derivative of cosine over here. That's the antiderivative. That's the sine. So 7/5 sine of 5x plus c. 7/5 sine of 5x plus c. Now I got 2 more. One make you think, and then the other one's going to make you really think. These are all test questions that I'm showing you, and this next one's a test question. But the last one, it probably would not be a test question, but might be a bonus question or one to make you think. So add. So I'm going to just do the short one first. The short one is the next one. 4 sine x over 3 dx. All right? Now, the reason I'm showing you this one is because the x over 3, some of y'all will just sit there and stare at it. So you got to rewrite that x over 3 to where you'll say, okay, the derivative of this is this. Instead of looking at it like x over 3, you need to look at it as something x. Anybody got a suggestion?
Quit.
Quit. Good job. I like that. That shows motivation. I'm going to bring the 4 out because I know that 4 and 3, they don't work too good together. So I'm just going to bring the 4 out, put a blank, sign. How am I going to rewrite that x to the third? I mean, x over 3. Now you can finish it because I've set it up for you. If I gave 10 students this problem, 5 or 6 of y'all would stare at that x over 3 and not know what to do with it until 5 or 10 minutes later, probably figure it out. All you got to do is write it as 1/3 x, and now you know what the derivative is. So u is equal to 1/3 x. Therefore, du is equal to what? 1/3 dx. So I've got to put a 1/3 here, and I got to put a what out here? 3. -12 cosine 1/3 x plus c. I bet some of y'all are even skipping a couple of steps, but you don't want to admit it. All right, here's your challenge. Antiderivative sine 4x cosine of x dx. Now this is what you're heading toward with second calculus. You're going to see more of these in second calculus. Anybody have any idea what I'm going to make u equal?
The higher power.
The higher power, but I'm not going to make it sine 4x. I'm just going to make it sine of x. Because what is the derivative of the sine of x?
Negative cosine.
No.
The derivative is cosine.
Wait.
So u is equal to sine of x. So du
Sorry.
is equal to the cosine of x dx. Well, we've already got the cosine of x dx. So this is u to the 4th du. This is u to the 4th du. So therefore, the answer is sine to the 5th x over 5. Now, somebody count up. I think that's about 6 or 7 trig problems.
7.
Well, that should carry you for 3 or 4 problems on the test. Now, what do I want to cover? I want to cover definite integrals right now. And I'll probably do that on my little board here because I have a little bit more control with my board till I get used to that other board. So I'm going to hit that and this. Now, I want you to look at these two graphs that I'm going to put on my document cam here. I'm going to put two graphs up here. Okay, somebody tell me what those two graphs are. From all your Algebra 2 and Algebra 2 review in here, and what are those two graphs of?
Square and cube.
F of x is equal to x squared, and f of x is equal to x cubed. What can you tell me about these two functions? What can you tell me? I know one's a parabola and one's a squiggle, and you know, one of them is x to the second, one of them's x to the third. But what can you tell me about these two?
One's even, one's odd.
I can't hear you.
One's even, one's odd.
One is even and one is odd. So one is even, that means it's symmetrical around the what?
Y-axis.
And one is odd, meaning it is symmetrical around the origin. Is that important? L to the I. Because if I ask you to give me the area from -2 to +2, under the curve, there's two ways to do it. And I'll do it over here too. -2 to +2. Any you pre-cal or calculus people can tell me the two ways to do these two problems? Anybody want to take a stab at it?
I can tell you one of them.
What should one of them?
Take the area under one of the two sides and multiply it times 2 for the even one, and then subtract from each other.
Exactly. You can actually do it that way, and another way is just do it from -2 to +2. But you'd have to go from -2 to 0, and then from 0 to 2. And this one would be -2 to 0 and 0 to 2. So that's two ways to do it. So you can set this one up as -2 to 2 of x squared dx. Or you could set it up from -2 to 0 of x squared plus 0 to 2 x squared. Or you could do it like this, and that's what they're trying to show you in 5.2, I think, and 5.3. They're going around the world trying to show you. Or 2 times the antiderivative from 0 to 2 of x squared dx. Now somebody tell me why I'm highlighting this one and saying this is the best way to do it. There's a reason, and it's not because of the 2.
It only works for a symmetrical even graph.
Well, yeah, they only work for symmetrical, even and odd. That's true. But there's why am I highlighting this one? I could use this one, 1, I could use this one, option 2, or I could use this one. Why did I pick this one? And it's not because of the 2. Nobody wants to guess?
I don't know if there's a lag on my end, but okay.
Yeah, you're still drawing the square for me. Right up.
I'm like, all I'm catching is the little stars you're drawing.
Okay,
Yeah, same with me.
I'm sorry. I don't know. I've got everything turned off at my house, so I don't know. Let me
It was,
turn the
it was doing
projector.
fine before, but I don't know what just
Let me
happened.
turn the projector off. And let me exit out of
I thought you
this.
were asking like why we should pick which corner.
Right. Yeah.
I don't know how to get out of that, so I guess I could just have to wait. Okay.
Because you
So-
only have to once is the answer you're looking for.
Why have I got you can do all 3 of these methods. Why do I have this one? And it's not because of the 2.
Because you only have to solve it once.
Well, yeah, that's because of the 2. The reason is I'm utilizing what?
The
I'm pointing at it.
coefficient?
0.
0.
Why do you want to utilize 0?
Right.
Because
so
what will it do to the whole function?
make it equal to the top one, the 2.
It will cancel out the whole function. What is 0 squared? 0. When you are dealing with with definite integrals, always try to utilize 0. Always try to utilize 0 because 0 will cancel most all functions out. Unless you got like a +1 or something added to it. It's going to cancel that x squared out. And you're not going to have to subtract any math when you utilize that 0. Same thing here. I'm going to multiply by 2. And I'm going to take the antiderivative from 0 to 2 of x cubed dx. So let's do that. Let's do these 2 on the next page. So go over to the next page, and we're going to do these 2 antiderivatives. And they are not antiderivatives now. Now they are called definite integrals because you are taking the area under the curve between 0 and 2. So I'm going to go to the next page. And 2 antiderivative of 0 to 2 of x squared dx. Now you don't have to worry about this because it's just the power rule. So what is the antiderivative of x squared? X cubed over what?
3.
Over 3, evaluated at 0 and 2 and multiplied by what?
2.
2. Now remember, you can distribute that 2, you can leave it out front. I'll leave it out front. Because at the very end, whatever you get, you're going to multiply it by 2. So really concentrate on the inside of the brackets here. Don't worry about that 2 until you get finished. So I've got to evaluate, which means I've got to subtract. So I'm going to take parentheses cubed over 3 minus parentheses cubed over 3. And I'm going to multiply that by 2 and put a 2 here and a 0 here. And what happens to the second term?
It goes away.
It goes away. And that's why you utilize the 0 in calculus. When you're doing a definite integral, always try. You're not going to be able to do it all the time. But if you've got a symmetrical function, an odd or even function, utilize that 0 instead of going around the world. Unless you just like pain and suffering. So that's going to be 2 times 8 over 3, which is 16 over 3, which is what? 5.33 repeating square units. Y'all check my math. I think it's 5.33.
Sounds right.
Say again?
Sounds right.
Golly, y'all talking soft today.
He said it was right.
Okay. So this is a prime example of a definite integral. It's also a prime example of one I would give you on a test. So let's do x cubed now. So 2 antiderivative from 0 to 2 of x cubed dx. And that's power rule because you just got nothing but a power, so you just do it. So 2 brackets x to the 4th over 4 evaluated at 0 and 2. 2 brackets parentheses 4 over 4 minus parentheses 4 over 4. 0 goes there, 2 goes there, and we take out that. Now, of course, you don't have to do this every time. Remember, I start from the bottom. After you do 2 or 3 of these things, you'll start leaving this off. You'll just start doing this right here. You'll start leaving that off. Okay? Because there's no sense in writing it when you're going to cancel it. So that's going to leave us with 2 brackets. 2 to the 4th is 16 over 4, which is what? Is it 16? I think it is. 16 over 4 is 4, isn't it?
Yeah.
And that's 8 units squared. Now, the reason I put units is because, especially in a science class, you got to make sure you put the units or they have a connection. So that's why I keep putting units squared, because we are finding the area under the curve. And that's your definite integral. Now, you need to take what you've learned about integration and apply it to definite integrals. So let's go ahead and start with a couple of problems. Now, the way that you'll tell they're symmetrical, one is you know it's a parabola. You might want to graph it to see. Now, I don't know if these are just antiderivatives that I picked up. So I don't know if these, I know the next ones that I've got are symmetrical, but these are just basic, which I'm trying to find it. There's, okay, number 1. Okay, there they are. Okay, I had to turn to the next page. Okay, here is the first one. Antiderivative, or integral, sorry, from 1 to 4. This is not a symmetrical one because they're going from 1 to 4. 5x squared minus 8x plus 5 dx. Now here you're going to take the derivative, add your antiderivative, you're going to do your parentheses, and you're going to plug and chug and subtract. This is a basic integration. It goes basic, definite integral, then it goes to a multiplicative, which is the times 2. Those are the 2 types of definite integrals I'll give you. Okay, I come up with that. Y'all check mine, check yours. 5/3 x cubed minus 4x squared plus 5x. Now, again, as I told you before, what is this called? It's called the setup. Sometimes you may be on a test or homework or taking a test in another calculus class, and they just want you to set it up. It'll say in the directions, just set up the integral or set up the definite integral. 5/3 parentheses cubed minus 4 parentheses squared plus 5 parentheses minus 5/3 parentheses cubed minus 4 times parentheses squared plus 5 parentheses. Now I'm ready to plug and chug. 4, 4, 4, 1, 1, 1. Oh, the things I do for y'all.
When we get done with this one, if we can go back to x to the third power.
I'm sorry, say again.
When we get done with this one, if we can go back to x to the third power, I'm like 99% certain the answer is 0.
No, you're using the negative. You can't do that. The area cannot be negative.
The net area would be 0 though.
The area can't be 0 if you have two. You have two areas. X to the third. Yeah, 0 divided by 4 is 0. 2 to the 4th. I get 8. You're not going to have two areas cancel each other because area cannot be negative. That's like saying you have negative ½ acre of land. The negative tells you, the only thing the negative tells you with area is it's on the left side or under, left side of the x-axis or under the y-axis. That's all it tells you. So if you did it the long way and you got a positive area and a negative area, you would take the absolute value of both areas and you should come out with 8. Area and distance cannot be negative.
Because they're scalars, right?
Good job. Dang old vectors. Tell you what. Dang old physics. All right.
Don't get her started.
I tell you what, dang old magnitude and dang old direction. All right. So 4 to the third power, I think that is 64, is it not? I always get 4 to the third power mixed up. 4 to the third, is that 64? 4 times 4 is 16. 16 times 4, I think, is 64. Y'all check me. So that's going to be 5/3 times 64. Minus, and this is going to be 4, basically 4 to the third power, which is 64 over 1, plus 20 over 1. Now notice I'm making everything fractions because I've got a fraction right there, and that turns everything else into a fraction. Minus, brackets, 5/3 minus 4 over 1 plus 5 over 1.
John didn't have to stay in Augusta today.
Is that a question or somebody talking?
Miss Bailey, can we get a mute, please?
All right, so that's going to be 5.
Sounds good.
Let me just go to the next page. Let me fold this. That's going to be 5 times 64 over 3. Now, you could take that 3 and that 64 and maybe, nah, that wouldn't work because that'd be a 34. That wouldn't work. So 5 times 64 over 3. Now you're seeing why some teachers just want you to set it up, because this is like basic math stuff. Hope I get it right. And that's going to be 3. 64 times 3 is 192. Somebody check me. Plus 3, 60. Somebody check my math there. Minus 3, 5, 3, 12, 3, 15. I just got a common denominator. And 5 times 5, see if that's 320. I believe that's 320 over 3 minus 192 over 3 plus 60 over 3 minus 5 minus 12 is negative 7. I hate subtraction. Negative 7 plus, that's 8 over 3.
Yes.
320 minus 192. Well, 320 minus 200 would be 120, so that'd be 128. Somebody check my math.
That's correct.
128 plus 60 is 188. Minus 8 is equal to 180 over 3, which is equal to 60 square units. Now you see why they just want you to set it up, because this is a whole page of nothing but basic math. So sometimes you're going to see them say, set up the antiderivative. Now, Mr. O'Quinn, back to your problem.
I just sent you an email if you want to.
Well, I know what you're thinking. I bet you did it this way or this way. Did you do it like number 1 or number 2?
It's the way the homework is asking for it to be done.
Okay, they're asking a different way.
Yeah.
Okay, we'll look at it. I'll look at it after class. Okay, now let me give you a couple of problems to work on for homework, and you should be able to do most of the homework now, 5.1 through 5.5. Now there are some homework problems that want you to think a little bit. I wouldn't, you know, you can think about them and try to do them, send them to me. I've got 4 to go over. They're usually the Riemanns. So, you know, Riemann, however you say his name. Send them to me. I'll go over them. You're probably going to send the same questions. I'm not worried too much about Riemann. I think that's 5.1. But 5.2 through 5.5 is, there's some good questions in there. Not many, but there's some good ones. And I might post some PDF questions also, just for you to do extra practice. All right, so here we go. Let's do antiderivative. I'm just going to write these down for you, and you can try them. Antiderivative from 1 to 9 of x to the 3/2 plus 2x plus 3 dx. That's one. I'm going to give you 3 short ones. Here's another one. 1 to 4 of 5 over x cubed. I would rewrite that first. Dx. And let's do this one. Antiderivative from -1 to 2 of 1 plus 3t times t squared dt. Now, what could you do on this one before you get started? You
Just
could
let me
actually,
know it's 425.
oh no, what could you do on that third one before you actually get started?
I'm gonna go ahead and quit.
Okay, well, you could distribute that t to the second. That's what I would do. Okay, so anyway, let me, actually, you do substitution also, but you could distribute that t because this is not to the 5th power or something. So, okay, let me shut her down. I don't want y'all to have convulsions. Okay, let me shut off the recording. And